Carlos Ramirez, owner of NVSAUDIO in Roselle, New Jersey. We got another wiring rescue here. This beautiful, beautiful slingshot came to us after we built the 2020 slingshot we delivered last month. So the other slingshot we delivered was a simple stage 3 6-speaker bike. This customer is very upset, they're friends, because the bike we built was louder than this bike and had half as many speakers. This bike has 12 speakers on it. It has 12 speakers, 3,000 watts of amplification. He's having power issues. The battery keeps going dead. It's not loud, sounds distorted. He is very, very, very upset. So we went over it and we immediately found a few problems that need to be addressed. Check it out. Okay, the problem begins here. Here's a Rockford Punch 1000 running 2 P1 subwoofers. Out of pure laziness, they grounded it to the seat bolt. These bikes don't have a good electrical system to start with, so you have to run the wires directly to the battery. So this, just by pulling the seat, I already saw the first problem. Then on top of that, they're using cheap CCA wire, which I already knew was going to be the case. So then wires are just thrown under the seat like that. This is exactly, I haven't done anything yet. This is exactly the way we found it. Then at the battery. So the battery's loose, first of all. Then, right on the cable, it says this cable can handle 60 amps of current. So JL Audio makes it nice and easy for any tech to understand the current handling capability of the wire. So that's 60 amps for this wire. Now the issue with that is, if you read right here, we have 40 amps plus 50 amps plus 50 amps. And that's just what the bike needs for itself. So that's 140 amps. This cable by itself, says right on the cable, can only handle 60 amps. There is no other cable at the battery. You saw the amplifiers are grounded to the frame. So that means the 300 amps of current that the 2 amplifiers draw, grounded to the frame, plus the 150 amps, or 140 amps that the motorcycle needs, all have to run through this ground wire. They could have simply avoided that issue by running the 2 amp grounds here. Then it gets worse. When the customer complained about the battery draining issues, they installed the battery cutoff switch. So to make it nice and inconvenient for the client, he turns the switch off so the battery won't die, and then to ride his bike, he's got to turn it on, which resets the radio, and he has to reset all his stations and his Bluetooth. Here's the amp on the other side. So we have a 1,000 watt amp on that side and a 2,000 watt amp on this side. Grounded to the body. Look at these connectors. I'm afraid to ask how all these speakers are wired if we have these 2 terminals empty. We have all the wires jumped to this terminal, so I'm assuming they burnt one of the channels on the amp. So this amplifier runs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 speakers. Then that amplifier runs 1, 2. You have a circuit breaker, wire tied to the frame. So when this breaker trips, the customer doesn't have access to it from inside the bike. This could have been moved under the front seat. And they use this cheap aluminum eBay wire. Then the worst part is it runs to the cutoff switch. So you got to remember, the current from the entire system runs through this switch, and it's loose. So this setup never, ever, ever stood a chance of working well or playing well. little trim they made for the radio with hot glue, of course, fell in. Let's see if we can make this a little bit better. Okay, as we were taking it apart, we saw some sparks flying. So, I see why. Because we have a positive terminal adapter sticking out unprotected. And then we have 0 gauge in and 4 gauge out. Let's see. Ah, there's the smoke. All right, there was the problem there. We have an aluminum battery mount, and then they use the side post adapter. So when the battery moved, it would ground out against the adapter plate right there. Super duper duper dangerous. That's why on the Trackhawk, we made it out of plastic so that wouldn't happen. So Brian's gonna put the test leads on the first of the 2 channels hooked up to see what speakers move. Go ahead, Brian. So that's these. Go ahead, Brian. And the outside ones. So we have 8 speakers on the first set of channels. Move to the second set of channels, Brian. Go ahead. All right, so that's 4 speakers on the second set of channels. Brian, go ahead and check the impedance of each one of those lines. So 4 4-ohm speakers in parallel should net us 1 ohm. And there we are, 1.2 ohms, 1.1 ohms. So now, I went on the website for the Taramps. Now let's make sure it's the same model. So there's the 2 ohm version, same amp, 2 ohm version. So when we go down here to the specifications, it tells us that the maximum power the amplifier will give us is 300 by 4 at 2 ohms. And it'll do 192 watts at 4 ohms. This amp is not 1 ohm stable. That's why they can't get this thing to play right. That's why it's shutting off and it's not playing loud and going into protection. This is wired wrong. This is the wrong amplifier for this application. This is never, ever, ever going to work.